Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject network analysis and control systems. In that first part, that is two-port networks, in that we have seen many two-port networks and different parameters. Today we will see with a new topic. We have already done with one-port network and some of the two-port networks like admittance parameters, equivalent networks, impedance parameters, transmission parameters. Today we will see hybrid parameters. Hybrid parameters. The hybrid parameters are defined by writing the pair of equations relating V1, I1, V2, I2 as if V1 and I2 were the independent variables. Same way, like before parameters, we are going to write two general equations. That is V1 is equals to H11I1 plus H12V2. I2 is equals to H21I1 plus H22V2. You need to remember these parameters equations. Why? Because in previous parameters also the equations are very important. In the same way for hybrid parameters also these equations are important. Either in this or this you need to remember to solve the problems. In question they will give you should do hybrid parameters or should find admittance parameters, like that they'll give. Accordingly you need to consider the equations. The hybrid parameters are written for this linear network only. Okay, two-port linear network. The nature of the parameters is made clear by first setting V2 is equal to 0. Thus, if you see when you are making V2 is equal to 0, this part V2 is 0. So, H11 is V1 by I1 when V2 is equal to 0. Then H21 is I2 by I1 V2 is equal to 0. When if you see V by I means what? It is impedance. So, short circuit input impedance can be told. Why? Because V1 and I1 is the input side. So, you can say it as short circuit input impedance. When if it comes to I2 by I1, it is a current gain, short circuit forward current gain. I hope you remember in previous parameters also we have found I2 by I1, V2 by V1, voltage gain, current gain, like that. This is current gain. Then letting now I1 is equals to 0. Now we made V2 is equals to 0. We got some equations. Now what we will do? We will make I1 is equals to 0. This I1 will make 0. When you make I1 0, it will be H12 is equals to V1 by V2 when I1 is equals to 0. If V1 by V2 means what? Voltage gain. That is reverse voltage gain. Why? Because gain how we will calculate is output current by input current. So it will be gain. So when it is I2 by I1, it is a forward current gain. But voltage also what will find? Output voltage by input voltage, V2 by V1. But we are calculating here V1 by V2. So it is open circuit reverse voltage gain, not forward voltage gain, reverse voltage gain. In the same way, we can write H22 is equals to I2 by V2 when I1 is equals to 0. I by V means what? Admittance. So it is open circuit output admittance, it is called. So if you see, there is impedance, admittance, voltage gain, current gain. So it is a mixture of different things, different parameters. So it is a hybrid parameter, it is called. Since the parameter represent impedance, admittance, voltage gain and current gain, they are called as hybrid parameters. The subscript designations for these parameters are often simplified when they are applied to transistors. Thus, H1, H12, H21 and H22 become HI and HR, HF and HO respectively, where the subscript denote what? HI is input, HR is reverse, and for forward H21 and output. Output HO is output. Okay, like that the subscripts are given. This is the basic knowledge of the main parameters of hybrid parameters. If you see, this is the table. In previous table transmission parameters, I guess I have even added for admittance or impedance parameters. I have put only this much table in the PPT, but we can convert from one parameter to another parameter. This table is easy for you people to easily understand how to convert. If you see, y. If you want to convert from y to z, you can use this. From y to h, you can use this. From y to t, you can use this. From z to y, z to h, z to t. H to z, h to y, and h to t. Like that, you can convert from one parameter to other. Than remembering this table, if you want, you can remember this table. If you can remember this whole table, better is you remember the general equations like v1 is equals to v1 is equals to i1 z11 plus i2 z22, like z12, like that equations. If you remember, it will be easy to convert. If you remember these formulas, no, there will be some confusion what to put, how to calculate. So better if you remember for each parameter, just remember the equations. Then it will be easy for calculating. We'll see some of the problems. If you see, there is a two-port network. These kind of networks have done for all the parameters. For the hybrid parameters also we will do this. How we will do? See, you will first current the mesh currents, that is I1, I2. Then the H parameters, you know. See, if you remember these equations, so it will become easy than remembering the formula. See, V1 is equals to H11 I1, H12 V2. I2 is equals to H21 I1, H22 V2. Okay, you need to remember these parameters. After writing the parameters, then apply KVL. KVL to mesh 1 and mesh 2. You know how to apply KVL and KCL. If you don't know, there are some videos of in module 1 for KVL and KCL. You can go and check out. So you can, and there are sums also. You can check them in module 1 playlist. Here apply KVL means you will write V1 minus I1, 1 into I1 minus 4 into I1 plus I2. Why? Because the two currents are moving in the same direction through 4 ohm resistor. So I1 plus I2, that is equals to 0. So V1 will becomes to 5 I1 plus 4 I2. Then if you see V2 minus 6 I2 minus 4 into I2 plus I1. This is with respect to second mesh. You will get as V2 is equals to 4 I1 plus 10 I2. If you consider here this equation, if you rearrange, I2 is equals to V2 minus 4 I1 by 10. It happens. Then if you see, I2 is equals to minus 2 by 5 I1 plus 1 by 10 V2. If you see, this looks similar to this equation, right? So this H2, if you compare that, then H21 will become minus 2 by 5, H22 will become 1 by 10. Simple. Then substitute I2. This I2 if you substitute, this I2 means with values I am telling, this I2 if you substitute in equation 1, then you will get in terms of which parameters, V1, I1, V2 you will get. See, here I1 and V2 is there. So you want I1 and V2 itself. Here and anyways V1 is there left hand side in the first equation. You should check in that way which parameters are there, I1, V2 or V1. In that way you need to substitute. Substitute I2 in 1. V1 is equals to 5 I1 plus 4 into what is I2 minus 2 by 5 I1 plus 1 by 10 V2. So V1 is equals to 3.4 I1 plus 2 by 5 V2. So if you compare this and this equation look similar. So H11 will become 3.4 and H12 will become 2 by 5. So these are the H parameters. Finally, you will write in this way. H11 is ohms. You know that V by I form you will get. So 17 by 5 ohms you will write. Here it is the current gain. So 2 by 5. Voltage gain minus 2 by 5. So there will be no units. For last one it is admittance 1 by 10. Yes, Simon says the unit. So you need to mention the units also. Why? Because this is hybrid parameters. For 1 kind of unit is there. So please do check it. Next question. If you see there is a 20 ohm and 40 ohm connected. 20 and 40, if you same how we have done for the previous problem, apply KVL, V1 minus 20 I1 minus 40 into I1 plus I2, you will get the first KVL equation. In the same way you will do for the second equation. When you are doing for second equation, V2 minus 40 into I2 plus I1, you will get V2 is equal to 40 I1 plus 40 I2. Then if you rearrange the second equation, you will get in terms of I2, I1 and V2. You want in this terms only, I2, I1 and V2. So H21 will become 1 minus 1, H22 is 0.025. If you substitute this I2 in the equation 1, then V1 is equal to 60 I1 plus 40. I2 is what? Minus I1 plus 0.025 V2. So V1 is equal to 20 I1 plus V2. So you will get H11 as 20 and H12 as 1. So if you write these parameters in terms of matrix, it looks like this: 20 ohms, 1 minus 1 and 0.025 Simons as the H parameters. Next, if H is equals to some parameters they are given, find the Y parameters they are asking. So we need to convert from H parameters to Y parameters. Initially what we'll do is, first we'll write the H parameters. How we should write? V1 is equals to 5 I1 plus 2 V2 and I2 is equals to minus 0.5 I1 plus 0.1 V2. Just a reverse way you are writing. Initially you used to get the equations and used to write the matrix. From matrix you need to write in the form of equations, that's it. But you need to know what it is, I1 or V2, V1 or I2 or the left side. Based on the equation, general equation, you can write it. After writing, consider equation 1. I1 is equals to V1. If you consider I1, if you take I1 left hand side, then V1 minus 2 V2 by 5. Then you will get I1 is equals to 1 by 5 V1 minus 2 by 5 V2. If you see, it is in the form of admittance equation. I1 is equals to V1 Y11 V2 Y12. So Y11 will become 1 by 5, Y12 will become minus 2 by 5. Simple, no? Then substitute this I1 in the equation 2. If you substitute in the equation 2, what you will get? I2 is equals to minus 0.5, 1 by 5 V1 minus 2 by 5 V2 plus 0.1 V2. So I2 is equals to minus 0.1 V1 plus 0.3 V2. This is the second general equation of the admittance parameters. So Y21 is minus 0.1, Y22 is 0.3. So Y parameters are all in Simons. So 0.2 minus 0.4 minus 0.1 and 0.3 are the parameters. Very easy. First, initially the matrix what they have given, no, we'll write that respective in the terms of H parameters. Substitute the values accordingly to the Y parameters required. So you will get the comparison with the Y parameters, you will get the Y parameters. That's it. Find the H for the two port shown in figure. Similar. Before sum, if you see, the sum was in this way, but here what they have done, the sum was in this way. Now they have removed this resistor and they brought it here, and the values are different. So we will see how to do. Same. Apply KVL. Apply KVL to both meshes. Consider two currents, I1 and I2, positive to negative. Then V1 is equals to 25I1 plus 25I2. V2 will become 25I1 plus 75I2. You need to know how to write KVL by now. Then I2 is equals to V2 minus 25I1 by 75. So I2 is equals to minus 0.34I1 plus 0.013 V2. So H21 will become minus 0.34 and H22 will become 0.013. So we got the H21 and H22 parameters. Now what we will do, we substitute this I2 in equation 1. If you substitute, what you will get? V1 is equals to 16.5 I1 plus 0.325 V2. So if you compare, H11 is equals to 16.5, H12 is equals to 0.325 as the H12. So the final H parameters are 16.5 ohms and 0.325 and minus 0.34 and 0.013 Simon. A certain two-port network is described by hybrid parameters. Determine the new H parameters if a 25 ohm resistor is connected in parallel with the input and the output. They are asking only that, this much. What they are telling, certain two-port network H parameters are given. What they are asking, they want the new H parameters if 25 ohm resistor is connected parallel with the input side and the output side. We will see how to do this. This is a little bit different question. We will see. Initially, how we can do 1 by Z1, 1 by Z11 new. Okay, 1 by Z11 new is nothing but 1 by, that is equals to 1 by H11 plus 1 by 25. They are telling input is connected in parallel. So input is nothing but impedance. So we are considering as Z11 new. Okay. So Z11 new is equals to 100. 100 is given as H11. So 100 into 25 by 125. We will get Z11 new as 20. Now you have took as this H parameter, new H parameter, when the input is has a parallel of 25 ohms is 20 minus 2 5 0. These all three parameters are same, only 20 got changed. For the new another H parameters, we need to connect output side a 25 ohm resistor and find the H22 for that. How to do? You know that H22 is admittance parameters. So admittance, what we should do, y into 2 new is equals to the H22 whatever is there plus 1 by 25. As it is in parallel, so 1 by 25 we are taking plus 1 by. Here it is resistance, so 1 by H11 we are considering, but here it is admittance, no need to consider 1 by. Directly you can consider H22 plus 1 by 25. So y22 new is equals to 0.1 plus 0.04, you get 0.14 as Siemens. So this is a new another H parameter when output side a 25 ohm resistor is in parallel. In exams and all, if they remove the 25, if they can put 50 ohms resistor. This method is same, maybe the value may be changed. Find the H for 2 port of the figure. Okay, here how to do? See, it is looking little bit complex, but it is easy only. How to do is, first initially we can calculate the voltage across this, right? How we can do? V1 is equals to voltage across this resistance. How you will get? If you consider this as I1, consider just this as I1. Okay, and this current is moving in this way, minus 10 power minus 5 e2. So as they are moving in the same direction, you will consider I1 plus 10 power minus 5 e2 into resistance 1 k ohm. Okay, I hope you are understanding. If you do that, then you will get V1. So after that, I1 is, you need in terms of I1 is equals to V1 minus 10 power minus 5 k V2 by k. So V1 will become 1000 I1 plus 0.01 V2. So if you see, it is in the form of V1 H11 I1 plus H12 I2. So H11 is 1000, H12 is 0.01. In the same way, apply KVL to mesh 2. Okay, apply KVL to mesh 2. Here also we applied KVL only in the initial, for this also it is KVL only, but directly we have put the voltage. Nothing but if you do KVL also you will get the same thing. Here apply KVL to next mesh. V2 minus 10k I2 plus 100 V1 is equals to 0. So you will get V1 is equals to 100 I2 minus 0.01 V2. Substitute this V1 from 1 to above equation. We need to substitute this V1 to above equation. Then what you will get? Above equation is nothing but this equation. So I1 plus 10 power 5 minus 5 V2 into 1000 is equals to V1 is what? 100 I2 minus 0.01 V2. If you substitute into that equation, then what you will get? I2 is equals to 10 I1 plus 2 into 10 power minus 4 V2. Here again it is in the form of I2 is equals to H21 I1, H22 V2. Okay. If you compare them, then H21 will become 10, H22 will become 20 to 10 power minus 4. So you got all the parameters of H. So simple. Find Y, Z and H for a 2-port show. See, 2-port they are given. Simply they have given one resistor. How to find? It's very easy, but it is little bit tricky you feel. But it's easy. Y parameters, how do you find? I1 is equals to Y11 V1 plus Y12 V2. I2 is equals to Y21 V1 plus Y22 V2. You know that Y11 is nothing but I1 by V1 and V2 is equals to 0. When you are making V2 is equals to 0, you are going to short V2 side. You are going to short the V2 side as V2 is equals to 0. Then if you see, this becomes V1 plus minus V1. So V1 is minus if I1 is the current flowing, then V1 minus I1 R, that is equals to 0. So Y11 is equals to I1 by V1, that is equals to 1 by R is the initial Y11. So to get Y12, so we'll take Y21. Why? Because even V2 also we are making 0. No, V2 parameter again, when you will get I2 by V2. I2 by V1. I2 by V1 when it comes Y21. So Y21 is equal to I2 by V1 when V2 is equal to 0. Again you are shorting V2 only. So if you see here, V2 is shorting, but you want I2 by V1. So here I2 is equals to minus I1. See, if I1 is flowing in this way, I2 will be flowing in this way. So I2 will become minus I1, right? So we will get as minus V1 by R. So I2 by V1 is equals to minus 1 by R sin 1. Okay. Then Y12 is equals to I1 by V2. Y12 is equals to what? I1 by V2, and V1 will become 0 now. So V1 0 means what? We are shorting V1 side. When you are shorting V1 side, then again if you see, I1 is equals to minus I2. So minus V2 by R. Again it is minus 1 by R sin 1. When you see again Y22, I2 by V2. See, it should be with respect to I1 V1 only here. I2 V2 only. Then only you can consider this in this way, that as a case KVL. But when you see Y12 and Y21, there are of different components like I1 V2. It is not of similar input. I1 by V1 it is not. And here is I2 by V1. So we need to consider I2 is equals to minus I1. Okay, here again it is I2 V2. I2 by V2. So V2 will become V2 is equals to R I2. So Y22 is equals to 1 by R sin 1. So Y parameters are this. The mentioned Y parameters are 1 by R minus 1 by R minus 1 by R and 1 by R sin 1. Now we will find H parameters. Finding H parameters is how? First write the H parameters. After writing the H parameters, H11 is equals to V1 by I1 when V2 is equals to 0. When V2 is equals to 0, V1 is equals to RI1. So we want what? V1 by I1. V1 by I1 will get as R. When it comes to H21, it is I2 by I1. So when V2 is equals to 0, it is coming in the terms of I2 and I1, not in the same port side, different ports. So I2 will become equals to minus I1. So minus I1 by I1 you will get as minus 1 as H21. Then H12. H12 is equals to V1 by V2, voltage. So V1 will be equals to V2. So I gain 1. Okay. Then H22 is equals to I2 by V2. So I2 by V2 is nothing but when it is I1 is equals to 0. I1 itself is becoming 0. Then I2 also will become 0. So H22 will become 0 sin 1. So R ohms 1 minus 1 0 sin 1 is the H parameters. Then now Z parameters. How to find Z parameters? You know V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. So if you want Z11, V1 by I1, when I2 is equal to 0. I2 is becoming 0 means V1 by I1, that is R only you will get. Then Z12 is equals to V1 by I2. It is in terms of V1 and I2. So then what we need to take? I2 is equal to minus I1. So minus V1 R you will get. Okay. V1 is nothing but V1 into R. No. I1 is equal to V1 into R. So minus V1 R. If you substitute that in the place of I2 minus V1 into R. Minus V1 into R. You will get minus R ohms as the Z12. Z12 is what? V1 by I2. Then Z21 is V2 by I1 when I2 is equals to 0. So I1 is equals to minus I2 we need to consider. So you will get minus V2R. So minus V2R. So Z21 will become minus R ohms. Then Z22 is equals to V2 by I2 when I1 is equals to 0. So Z22 is equals to V2 by I2, that is equals to R ohms. Again, so R, R is the Z parameters. The two networks of figure are connected in parallel by tying the corresponding input terminals together and then tying the corresponding output terminals together. Determine the new set of H parameters which describe the parallel connection. What they are telling is by tying corresponding input terminals, this corresponding input terminals together, this and then tying the corresponding output terminals, this and this together, determine the new set of bus. They are asking. We can do that. It's easy. How to do is, consider 50 ohm, 25 ohm and first circuit which is mentioned on the right side. Then if you apply KCL to node 1 and node 2, apply KCL to this node and this node. So I1 is equals to V1 minus V2 by 50 ohms only. So I1 is the incoming current. So I1 is the incoming current. Outgoing current is only V1 minus V2 by 50 ohms. So if you write the equations, then I1 is equals to 0.02 V1 minus 0.02 V2. So I2 is equals to V2 by 25 plus V2 minus V1 by 50. Apply KCL to node 2. So if you see, this is the incoming current going. I2 is equals to outgoing current is V2 by 25 and V2 minus V1 by 50. If you rearrange then write, you will get the second equation. I2 is equals to minus 0.02 V1 plus 0.06 V2. So this is the first I parameter. That is when the network K, if you consider this as a network K, that network K Ya is equals to, you get the parameters. Then for the network B, if you consider this as network B, then consider the currents I1, I2, V1, V2, 25 ohms and 50 ohms. Apply KCL to node 1 and node 2. If you apply for node 1, I1 will be the incoming current. Then outgoing current is V1 by 25 and V1 minus V2 by 50. If you rearrange, you will get I1 is equals to 0.06 V1 minus 0.02 V2. If you consider this node 2, for node 2 I2 is the incoming current. Then outgoing current is V1 minus V2 by 50. Sorry, V2 minus V2 by 50. Why? Because with respect to node 2. So if this is the node 2, this point is node 2. If I2 is incoming current, outgoing current for this node is V2 minus V1 by 50. So you will get as I2 is equal to minus 0.02 V1 plus 0.02 V2. So y the values also you will get in terms of signs. Now what they are asking, determine the new H parameters. How to find new H parameters can be found. They want new H parameters. But initially what we are doing, we are finding Y parameters of the both. So it will become easy. While in Y parameters, if you remember in admittance parameters, if something like this they are tied parallelly, then you can use, then Y parameters can be, separate Y parameters can be added up, you will get the Y parameters. It is given. In the same way, what we have did is here H parameters you want, but H parameters there is nothing like HA plus HP can be done. So if you initially find the Y parameters of the both networks, then you will get YA plus YB, the whole Y parameters of the two networks when they are connected in parallel. Now simply if you convert the Y parameter, the whole Y parameter of the network to H parameter you will get. So I1 is equals to, write in terms of Y parameters, that is 0.08 V1 minus 0.04 V2 and I2 is equal to 0.04 V1 plus 0.08 V2. Simply convert into H parameters. How? Consider equation A. 0.08 V1 is equals to I1 plus 0.04 V2. V1 will be equals to 12.51 plus 0.5 V2. If you see, this is similar to V1 H11 I1 plus H12 V2. So if you substitute this V1 in equation B, you will get I2 is equal to minus 0.5 I1 plus 0.06 V2. It is similar to H2 is equals to H21 I1 plus H22 V2. So you have already got H11, H12, H21 and H22. 12.5, 12.5, 0.5, 0.5, minus 0.5, minus 0.5, 0.06, 0.06 are the H parameters when two networks are connected in parallel. For that what we will do, simply we will consider for the network 1 Y parameters, network 2 Y parameters, add them both to get the whole Y parameters network. From that, if you convert to the H parameters, it is over. Why? Because we require here new set of H parameters. The two ports which plays a central role in circuit of figure can be characterized by hybrid parameters. H is equals to 1 ohm, -1 to 0.5 Simon. Determine I1, I2, V1 and V2. Okay. We want I1 value, I2 value, V1 value, V2 value. How to find? Apply KVL to mesh 1. If you apply KVL to mesh 1, 1 minus 5 into I1 minus V1 is equals to 0. So V1 will be equals to 1 minus 5I1. So V2 will be what? I2 into 2. So H parameters are, we know that V1 we already given with the H parameters. So you can write in the form of H parameter equation, that is V1 is equals to I1 minus V2. I2 is equals to 2I1 minus 0.5 V2. Okay. After writing it, what we should do is put V1 and V2 in equation 1. Put V1, this V1 and V2 in equation 1 and 2. If you put them, what you will get? 1 minus 5I1. V1 is 1 minus 5I1. That is equals to I1 minus V2. I1 minus V2 is what? 2I2. So 1 is equals to 6I1 minus 2I2. Then I2 is equals to 2I1 minus 0.5 V2 is what? 2I2. So 2I2. We will get equation 4. 0 is equals to 2I1 plus 2I1 minus 2I2. If you see here, solving 3 and 4, you will get I1, I2. I1 is what? 1 by 4 amps. I2 is what? 1 by 4 amps. So I1 and I2 you got to know. If you put this I1 and I2 in these equations, you will get V1 and V2. V1 will become 1 minus 5 into 1 by 4, that is V1 is minus 1 by 4. V2 is 2I2, 2 into 1 by 4, that is 1 by 2 volts. Simple. Initially we will write KVL is common. We write this H parameters into the equations. Then by doing this KVL you will get V1 and V2 values. Put this V1 and V2 values in this. So it will be in terms of I1 and I2. The equation will be in terms of I1 and I2. By solving using the calci, you will get I1 and I2 values. Put those I1 and I2 values in the V1, V2 equations. You will get V1 and V2. That's it. So these are the practice questions on hybrid parameters. I have given some 5 questions. All are simple. These type of questions I have solved. This also I have solved. This kind of question I have solved. This kind of question I solved for the transmission parameters. So you can check with that. Then this type of question also I have solved for the previous parameters. So please try them. They are easy. If you solve only network analysis is easy. If you don't solve them, it is not easy. You can't just see the things and mug up. This is not a theory subject. You need to take pen and paper and solve them. Solve it. It is easy. Then you can easily score. If you know the concept and if you are solving them continuously, then you will understand. So I will stop the video here. So now we are done with module 2. First chapter is done, that is 2-port networks. In that we have done with all the concepts. It is done, all the parameters. There are totally 4 parameters: admittance, transmission, impedance and hybrid. All the parameters are very important. In question paper compulsory they are going to ask the parameters question 1. Sometimes what they do, they give one question and ask for all the parameters. Do admittance, transmission, impedance and hybrid parameters. In previous question paper also they have asked in the same way. So please do all the parameters, remember those equations. So I will do the next topic, that is second chapter of the module 2 with a new video. So the next topic is Laplace transformation. I will upload the Laplace transformation next. So by this second module, first chapter is done. See, 2-port networks is done. Next is Laplace transform. As I said, I will do the videos for the next video. Thank you from Sri Sai Tech Edu YouTube channel. Read, Lead, Success. Keep reading.